And welcome back, Math 1. I'm going to talk to you now about a formula called the midpoint formula, and it'll add to our geometric toolbox, I guess you could say. So let's get to work here, and again, pause, take notes. You're going to need these formulas. Let's see what we got. Now, the first thing I've got for you, this is 8.3, midpoint formula, and what the midpoint is talking about the midpoint of a line segment. Right? A line segment's different than a line. If this thing had arrows on the ends, it would not be a segment. There would not be a midpoint. Right? You can't find the midpoint of something infinitely long. So this is a segment, and the midpoint would be like if you had a yardstick. Well, you don't say yardstick. Let's just say a stick, 4 foot long, and you say, where's the midpoint? Well, it's at 2 foot, right? Because if you break it in half there, you're going to have a 2 foot on each side. All right, so the midpoint is a little bit different because what I talked about just then was in one dimension. Right? So now if we go to 2 dimensions, and that's what this formula does, we're in the coordinate plane. And to find the midpoint in a coordinate plane, you need a location, not a length, it's not a distance, a location. All right, so the formula works this way. It's very, very simple. Okay. Basically, you do this. Now, I don't have the coordinates written here. I guess I should have. This is coming from ordered pairs, x1, y1, x2, y2. And all you do is you sum up your x values, divide by 2, comma, sum up your y value, divide by 2. So this is actually just an ordered pair. And it locates it directly in the middle of a line segment in the coordinate plane. So if you're given ordered pairs and asked for a midpoint, this is what you'd use. It also finds the center of a segment, the location of the center of a segment. So let me come down here and do a problem with you, a very simple one right out of the gate here. And so this one says, find the midpoint of the segment with the following endpoints. And we've got 8, 10, and 4, 4. So I'm going to go through and compute that with you really quick. And I've got to get my writing pad out here, my digital pad. And there's my digital pen. So, all right, so to calculate this, and I know you've probably already done it, some of you are really fast, a person would, we want the midpoint of a line segment through 8, 10, and 4, 4. All right, so really it's going to become 8 plus 4 over 2, just using the formula, 10 plus 4 over 2. Since we're adding, order doesn't matter really. So here I get 12 over 2, which is 6, right? 14 over 2 is 7. So your midpoint is 6, 7. All right, that's the first type you've got to be able to do. All right, there's another problem that I want to do with you, and it takes a little bit more time. So let me clear this out and go look at example 2. Example 2 gives a whole different scenario, and this guy is actually pretty common. The midpoint of segment AB, now this is the notation for a line segment, is 3, negative 1. The coordinates of A are 8, 4. What are the coordinates of B? Okay. All right, there's a couple ways to do this. One way is using graph paper or a graphing program of some sort. But I think I'll do it by hand first with a formula, and then I'll show you how to do it with a graph. All right. I don't know why it has a default with that bomb in there. Okay, so we know that our midpoint formula says add up the x's, divide by 2, add up the y's, divide by 2. Now they're telling me the midpoint is actually 3, negative 1, right? And it turns out that came from somebody adding 8 plus x over 2, and then they added 4 plus y over 2. This is the way I used to always teach to do this. And then somebody showed me the way they did it on graph paper, and I was like, oh, yeah, that's very easy too. So definitely some of you are going to like the other way better. All right, so I'm going to set x equal to the x coordinate. So 3 is equal to 8 plus x over 2. And negative 1 is equal to 4 plus y over 2. Cross multiply here, we get 6 equals 8 plus x. Subtract 8 from both sides, so we get negative 2 is x. Okay, so here cross multiply again. Get negative 2 is 4 plus y. So we get negative 6 is y. All right, so we found the midpoint was negative 2, negative 6. All right, so hold on to that for a second here as one way to do this, and you may have thought that was hideous. And if you did, you're in luck, because I got, I think, an easier way. So let's take a look at the easier way. And I've gone to GeoGebra. Now, I welcome you to Google GeoGebra and use it. But just remember, if you're on an exam or something like that, you can't use GeoGebra. All right, so that's the only problem with it. Okay, so what I've already done here is I have graphed our midpoint, M, and all I did was type it in, and I graphed A. All right, and here's the logic. This is a line segment. That means it's linear. It can't have a curve or it can't be crooked. It has to be in a straight line. If that's the midpoint, then it can't live up here above A. That's impossible. It's got to live down here somewhere, right? So one way to do this is say, well, let's do some block counting. It's got to have the same slope. And if you block count from A, you'd have to go down 5 over 5. And if you do the same thing here, you go down 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. And guess what point that is? That's that negative 2, negative 6. So B equals negative 2, negative 6. And there is the other coordinate. Now, again, to recap what we just did, we said since it's a line segment, that's the midpoint, then the slope from A to M has to be the same from M to B. So you block count your way down to it. And I've seen kids get it that way so many times. Now I make things kind of complicated with equations, and they'll go to a piece of graph paper and knock it right out. So graph paper, very effective for solving problems like these. Anyway, I hope you find this video helpful, and I'll see you in the next video.